Hey, astronomy kids. Let's go over some evidence for the Big Bang hypothesis, okay? Why do we have this idea of the Big Bang? Very basically, when we look out at distant objects, what we're finding is that they're moving away from us. Now, nearby objects, like the Andromeda Galaxy, only 2 million light years away, nearby, yeah. They're moving towards us, or some of them are moving towards us. We're in gravitational dances. Many galaxies are in these gravitational dances. But as soon as you get out, to 20 million light years away, everything is moving away from us. But more than that, think about, if you will, a loaf of raisin bread dough. Just makes your mouth water thinking about it. Okay, here we have a lump of raisin bread dough. And in it, of course, we have raisins. Now look at these raisins. The dough, as it rises, is expanding. Every centimeter of dough is expanding at a certain rate. So if we consider this raisin, well, this raisin is moving at a certain speed, going away from it. This raisin, twice as far, would be going twice as fast because there's twice as much dough. A raisin 3 times as far will be going 3 times as fast. And that is exactly what we see in the universe. Instead of raisins, these are galaxies. And what we find is that they're all spreading apart from each other. The farther we look in distance, the faster it's going away. And it's a fairly smooth curve. Okay, so we have the distance and the speed, right? So if we mark it off and we say we have a galaxy this far away, it's moving this fast. If we have a galaxy twice as far away, it's moving twice as fast, and so on. It's a substantial understanding. Edwin Hubble came to start believing this in 1929 after observing distant galaxies and measuring their recessional velocities. And we've confirmed it over and over again. As a matter of fact, there had been a prediction that if the Big Bang occurred, we should have a certain size wavelength everywhere in the universe from the initial burst of energy from the Big Bang. And after that prediction was made, it was clearly observed that exactly that form of radiation permeates the sky. We put up several satellites to examine that, and what we see is that radiation coming from everywhere in the sky, but it's not perfectly uniform. In some places, it's a little bit more dense than others. Exactly what you'd expect to end up in a universe that is, after all, lumpy. Go ahead, poke. Yeah, you're a lump. The Earth is a lump. Our galaxy is a lump in otherwise empty space. So you'd expect the observations to show little bits of density where galaxies would start collecting, or actually clusters of galaxies would start collecting. So everything we expected to find in terms of the expanding universe, we have found. Looking at the most distant galaxies, they are so far away, they're moving so fast away from us that their light, which would be mostly visible light, has been stretched way out. So it's largely infrared radiation instead. All of these ideas, we found them exactly as you'd expect them in an expanding universe. So that's the basic idea of the Big Bang. Why we live in an expanding universe. Hey, if it seems like you live in the middle of an explosion, you do. Thanks for watching.